So this video is going to look at composite functions. And composite functions are functions within functions. So there's going to be a few different ways that you might see this come up on the paper. So the first way here is just fg of x, and here we have just a little circle in between them, and here is it using square brackets. Now all of these above are read as f after g of x. So what that's telling us is we first complete g of x and then we put this into our f function. So it should hopefully make a little bit more sense once you see this. So in this example here we've been given two functions. So the function f is defined by f of x is equal to x plus 1. There's a second function which is g of x, and that's defined as x squared. So the first question has asked us to get f after g of 4. So let's take a look at how we do this. So the first thing we want to do is g of 4. Okay, so if you look at this as the one that most looks like the function, so g of 4 is something hopefully we can recognize and we can do. So let's do that first. So g of 4 in this case is going to be 4 squared, which is just 16. Now, once we have our answer, we're going to plug that back into f. So this time we're going to do f of 16. So f function tells us to take that x value, which in this case is 16, and add 1, leaving us with 17. Therefore, f after g of 4 is equal to 17. So we always do the inner one first. So remember that this is f after g of x. So we do g first and then we do f. So let's look at part B of this question then. So here asks us to do f after g of x. So they haven't given us a number to fill in. Okay, so just as before, let's take g of x, because that's what we're going to do first, and that is x squared. So that is our answer to the first part. We're then going to sub that answer into our f function. So it's f of x squared. So what that's telling us is that everywhere that we see an x in this, we're going to instead put in an x squared. So really we're going to be updating this piece here. So let's go with that. So instead of x, we're going to have x squared plus 1. And that's it. So f after g of just x is equal to x squared plus 1. Now, just to go back to part A, we could have done that by first working out f after g of x in general terms, so with an x, and then subbing in. So let's take a look at that. If I did f after g of 4, I would simply sub 4 into the formula just above. So it's 4 squared plus 1, which should give us 17, which was the first answer that we got. So it's just a second way of doing it. So let's look at example 2. This is where we can use composite functions. So they've given us two functions again. They've said f of x is equal to 4x plus 3 and g of x is equal to 6x minus k. Find k if f after g of x is the same as or equal to g after f of x. So notice that we're using a different notation for g after f of x than we had in the previous question, but both still mean the same thing. So let's look at how we would approach this. So let's take a look at this bit that they've given us here. So they've given us a little bit of an equation, and they've told us f after g of x is the same as g after f of x. So let's first work out the left hand side. So the left hand side in this case is f after g of x. Now what I often find is students find it easier when we do use that square bracket because it separates it slightly. So let's first of all do g of x. So g of x in this case is 6x minus k. We then want to put that answer into f. So it's f of 6x minus k. So remember, what we're trying to do in this case is everywhere there's an x in the f function, we are now going to put in 6x minus k. So let's take a look what that looks like. So it's 4, and now instead of the x, we're going to substitute in 6x minus k, and then we're going to add 3. So let's multiply out our bracket. So 4 6s are 24, so 4 by 6x is 24x, minus 4k plus 3. Okay, so that's the left hand side. So now let's work with the right hand side of that same equation. So we've done our left, let's look at our right. So it's g after f of x. So that's telling us that first of all we do the f part and then we do the g part. So let's take f of x first, and that is 4x plus 3, no substitution required. Now that's our answer, so we're going to plug that into g. So it's g of 4x plus 3. So just like before, we have to be conscious of what we're doing here. So in g of x, the x part is going to be replaced in this case by 4x plus 3. So let's see how that works for us. So it's 6 times. Now instead of x, we're going to put in 4x plus 3, and we're going to take away k. So cleaning that up, 6 by 4x is 24x. 6 by 3 is plus 18, and we have a minus k. Now, what they told us was both of these should be equal. So let's make an equation where the left-hand side, as we found it, plus 3, is equal to the right-hand side. So 24x plus 18 minus k. Now, straight away, we should hopefully see that the 24's cancel on both sides. And then I'm going to bring a k across. So we have minus 4k on the left. I'm going to bring the minus k across. So we have minus 4k plus k. I'm going to bring that plus 3 across as well. So that becomes a negative 3 over here. So what we're left with, 3k equals 15. Therefore, k equals 5. So to get that last part, we're dividing both sides by 3. So this is an example of how we can use composite functions to find missing elements of a function rule. So in this case, it was the constant. So this is our last example here. So finding a function using composite functions. So in this case, they've told us there's a function f, and it's defined as f is equal to h after g after j. Okay, so in this case, we don't just have 2 anymore, we have 3. So just like before, we're going to work from the inside out. So let's rewrite this in a way, I suppose that looks maybe a little bit easier for you guys. So that there's h of, g of, j of x. So this is what we're doing, and we're just working from the inside out. So the first part we're going to do is going to be j of x. So that's the first bit that we're going to fill in. So instead of j of x, we're going to say x plus 2. So what that looks like for us then is f is equal to h after g of, and instead of j now I'm going to put in x plus 2. Okay. Now, with the g, what we're doing is anywhere there's an x, we're going to replace it with x plus 2. So let's do this. So I'm going to work aside here for a second. So g of x plus 2 is equal to x plus 2 to be squared. So let's square that out. Now, if you've issues squaring out brackets with using the shortcut, do write it out twice, do break up your brackets, whatever you need to do. I'm going to use the shortcut here. So it's square the first, twice the first by the second, and square the second. So sorry, that should be plus 4. Okay, so we're going to put that back in. So over here now, f is equal to h of, and it's going to be x squared plus 4x plus 4. Okay. So what they've told us is f of 2 is equal to 32. So since we're down to one function now effectively, what we can say is h of x squared plus 4x plus 4 is equal to 32, but only when we sub in 2 instead of x. So let's look at this. So it's h of 2 squared plus 4 times 2 plus 4, and that should give me 32. So cleaning all that up, and you can work it out, but we'll basically get h of 16 is equal to 32. So when I plug the number 16 into some function, it gives me an answer of 32. So now notice how in the question they asked us to define a function h. So there are multiple functions that will work. Since we've only been given one answer here, it's impossible to know which one is the correct one. So any could be accepted. However, the most straightforward one to see here is that we would simply multiply our x value by 2. So what that will give us is h of x is equal to 2x, and that would be our answer. So we have to look at our x value, which is 16, and our y value, which is 32, and ask ourselves, what are we doing to get from that x to the y? What is our rule? And in this case, 2x is a completely acceptable answer. You might also say that you add 16. However, I suppose it's less likely to be simply x plus 16, but like I said, we've only been given this 1 point. Since we've only been given this 1 point, f of 2 equals 32, then I suppose we can't really say which one is right and which one is wrong. So if you want to say x plus 16 for this question, that's absolutely fine. So really that's everything that you need to know about composite functions. My advice would be just to make sure that you're comfortable with the order, that you're starting from the inside out, and especially given this example 3 where maybe the x's were left off, that they do mean f of x is equal to h after g after j of x. So if you want to, you can rewrite this to make yourself more comfortable. And as I said before, you know, the use of square brackets or even just extra brackets can make your life a little bit easier when it comes to these questions.